Hi, my name is Qunying. I'm a PhD student at Lund University in Sweden, and I'm going to present our paper, Concepts in Testing of Autonomous Systems, Academic Literature and Industrial Practice. There are already a lot of examples of autonomous systems exist. The self-driving cars, the automated fighters, and the robodogs, which can be used for many different purposes. In addition, we also have this smart software that are used for business and trade in the digital world. So how is the concept of autonomous systems defined? What are the principal challenges related to testing of autonomous systems? Are there any approaches and practices for testing of autonomous systems are used or proposed? In order to address these research questions, we have conducted a multi-method exploration study. Well, first, we conducted a semi-systematic literature review based on 45 papers on testing of autonomous systems. Then we organized a focus group discussion with 8 industrial practitioners to get insights from the practitioners' point of view. Lastly, we conducted another 4 interviews towards 5 experts from the industry who we know are working with autonomous systems so that we can consolidate and validate our findings from the previous activities. By synthesizing a semantic model based on the literature and the industrial practices, we have proposed a conceptualization of autonomous systems. We have presented a classification of challenges for testing of autonomous systems. And also, we presented a classification of available techniques and approaches, as well as the current practices for testing of such systems. So we have conceptualized that autonomous systems are capable of performing certain tasks in an unstructured environment without human supervision. There are 4 key characteristics about autonomous systems. First, the system must be self-aware of the environmental conditions and the system's own states. Based on the perceived information, the system must be able to analyze it and do the decision-making. Over the time, the system must be able to adapt its behaviors according to the goals and based on the historical data. Lastly, the system must be able to actuate the plan that is derived from the decision-making. Our conceptualization is inclusive to both the system in the physical form and in the digital form. In addition, we have incorporated not only the systems that are self-evolving, but also the systems that are rule-based. So the rule-based system can still hold some level of autonomy in handling the task. The challenges for testing of autonomous systems. Well, first of all, the system can run into any unpredicted environment that is unknown during the design, which essentially leaves us an infinite set of scenarios to cover during the test. The challenges also come from the complexity of the system, the scenario, and the modeling of them. More specifically, the system is complex regarding its architecture and design. Especially nowadays, there are more and more machine learning and artificial intelligence components that are involved. It is really difficult to define, to track, to report, and to reproduce the scenarios for testing. And the testing is highly reliant on the modeling of the environment, the system, and the interactions dynamics between them. Data accessibility is a key since we need extensive data for both testing and training the system. In addition, we are lacking of industry standards and guidelines on how we can test the autonomous systems. Fortunately, there are some practices and the technologies that has been proposed for testing of autonomous systems. There are some industry standards that are available, such as ISO PAX 21448, which is a newly published standard that can be used for design and validate the autonomous vehicles. And also there are a list of engineering recommendations that are proposed. Among them, using the simulation techniques has been articulated a lot by the literature and also the industry practitioners. So we should utilize the computational power and also simulation to do the virtual testing of the autonomous systems. And further, we should combine the virtual testing and the real-world testing together. We need to break down the test to different levels, to different units, using the V-model paradigm. And we need to collaborate so that we transfer the knowledge across different domains. And we are encouraged to open source the dataset, the tools, and the frameworks, so that instead of creating your own, we can reuse the existing work. Moreover, we need to realize that the testing of autonomous systems should be conducted iteratively and continuously. There are some available techniques and approaches that have been proposed both from the literature and by the industry practitioners. Most of them are actually the adaptation of the conventional approaches to address the system autonomy. For example, the model-based testing and the firmware verification has been used to model the system behaviors and generate test cases. Combinatory testing and search-based testing have been used for exploring the test cases and to reduce the number of test cases. Particularly, we have this scenario-based testing, which instead of trying to cover all possible scenarios for the system, we try to identify the most critical scenarios for testing. And there are also a lot of other techniques that have been proposed, which you can read the details in our paper. So, as a summary, testing of autonomous systems is critical to ensure the quality and the safety of them. Our findings can serve as a frame for the future research on testing of such systems, and it can also be extended by including more aspects of autonomous systems and to include more autonomous domains. Thank you.
Hi all, good to see you. Now we are finally on the air from backstage. I'm Runeson and sharing this session, and here with me I have Qunying Song, who with me is co-author of the first paper. Thanks Ivica for being active in the chat. And we are referring back to the presentations yesterday, and both John and Lionel had improvised presentations. Reproducibility, we start talking about that. So, Song, do you have seen anything in this work about specific challenges with autonomous systems with respect to reproducibility?
Yes. We mentioned a principal challenge in reproducing the scenario, especially for those crashing case or near crashing case in the real, for example, the traffic scenario, which is really difficult to reproduce in the test environment.
So that's one of the specific challenges. And another issue that you have been researching here is whether or not autonomous systems must have a physical representation. What have you seen in the literature? Is there an agreement on whether or not autonomous systems must be physical?
No, according to the existing literature and also in the interview with the industry practitioners, I think it can be referred to the system in the physical form, like the self-driving cars or the robotics, which integrated with a lot of like hardware components. But it can also be referring to those systems that are purely software system, for example, used for the business and trade.
Right. So, is there any principal differences between? I mean, of course, there is more direct risk for harm with robots and cars of people. But have you seen any major difference, or autonomous system is similar?
Yeah, I think they are common in terms of like they should react to the environment or different situation autonomously. But basically, they are very different because mostly those cyber-physical systems can be safety critical, while like in the digital world, the software systems are mostly like mission critical instead.
Right. That's an important distinction.
Mm.
So, in the type of research I mentioned in the chat here, that there are many building on traditional testing techniques. Did you find any really novel approaches to testing of autonomous systems?
Well, mostly those approaches we have been surveyed through were the adaptation of the conventional testing approach that was used for testing those classic software systems. But there was one approach that was articulated by an interviewer, which is who is an industry practitioner. That is a scenario-based optimization approach, which is to optimize and identify the most critical scenarios for testing instead of exploring all possible scenarios.
Right. So that's one line of research which is novel for autonomous systems and definitely much needed. Ivica also writes about uncertainty. What in addition to continuous change, we must have continuous testing in the runtime environment. What is your reflection on that, Song?
Yes, that's true. The autonomous systems have we're running into a very uncertain environment, and initially will lead to a very dynamically changing behavior. So what I would think that in the test we have to be really flexible in adapt to the different environment